Alright, so we have a problem which is based on work, energy and power, and then it's on question 5 of question 2023 there, see June exam. So they're saying a Skya having a mass of 80 kg starts from rest at point A. You can see this is point A, the person starting from rest, okay? Meaning when someone starts from rest, it means that the initial velocity is basically 0 meters per second. Please keep that in mind. Alright, good stuff. Then from there, and skies down a frictionless slope. The minute you hear about a frictionless, you must understand that the surface is smooth. There is no presence of frictional force there. You get it? Awesome. And then as soon as you can see, the sky then moves past point C, then it's going up there until D, until it comes to rest. Okay, meaning the final velocity here of the person is going to be 0 meters per second again. Sharp. But when he was moving from point A to point C, I believe that he started getting some speed. Obviously, what's going to make that person to go down? You get? Yeah. So there's going to be some final velocity that you got to calculate, I guess. Okay. Also, the same speed, which is your final here, is going to be your initial so you can get to the point D. Making sense, right? I mean, think about it. Like, move from point A to point C. That speed, the same speed as soon as so move for that momentum here. But as soon as I remember this loop, it's steep, speed size decrease until it comes to rest. Isn't that making sense? Yeah. Okay. Sure. Then they said to us, define a non-conservative force from 5.1, and then my helper here was assisting me, and then she said that a non-conservative force is a force that is basically dependent on the path taken, and it makes mechanical energy not to be conserved. Hello? Whenever there is a non-conservative force, mechanical energy is not conserved, and the same non-conservative force depends on the path taken. The displacement basically depends on it. You get, what are those forces that are non-conservative force as examples? Your frictional force whenever it's present, your tension, your force applied, those are the three I can try to give you. Alright. Then there is also a conservative force, which we say it is independent of the path taken and it makes the mechanical energy to be conserved. To meaning mechanical energy is not changed into other forms of energy like heat energy and stuff. But whenever those people are there with friction, you must know what's going on. Right? The only force that is a conservative is called force of gravity, Fg. Alright? Awesome. So 5.2, they said name a conservative force that is exerted on the Skya, okay? While he moves down, there is only one conservative force. So this guy, he experienced that force, which is called Mr. Force of Gravity, Mr. Fg. We are sorted, right? Good stuff. 5.3, use energy principles and calculate the speed of the Skya at a point C. My people, there is a formula which is given as work net equals to the change in EK. This guy, we call him Mr. Work Energy Theorem. Work energy theorem basically states that the work net done on an object equals the change in the kinetic energy of an object. The work net done on an object, if this is an object and I'm applying a force, and there is also another force that is experienced by the object, so we're basically saying the work net done on this object equals the change in the kinetic energy of an object. That is what we call work energy theorem. You can only use this formula if there are no non-conservative forces. Are we together? Yes. 2. Another formula you can use. EP equals EP initial plus EK initial equals to EP final plus EK final. Meaning initial ME, let me write it nicely. Initial ME equals to in final ME, which is the mechanical energy, right? So this is the formula that she has applied. I don't know if you can be able to see that, but then and then we are basically asked to calculate the speed of the Skya at the point C. So we have to use the energy principles that do not involve any non-conservative force. Please put that in mind, all right? Thank you so much. So we have applied that, we got that, it's in the positive direction, meaning it's going downwards, it's not a big deal there. So now, sinenkinga. Inkinga nasi bafethu. Inkinga. Inkulu. Ash. We are being asked to determine someone here. Listen to the question. The skier experiences an average kinetic frictional force of 160 newtons while he moves from point C to D. From C to D, you can see that the slope is very rough, isn't it? Yes. So there is Mr. What? Frictional force there with a 160 newtons force. Alright? Cool. And we know that as soon as there is Mr. Friction, we already have non-conservative forces present. Now, what is the examiner asking us? Draw a label free body diagram that will show all the forces exerted on the sky while it moves from point C to D. There is Fg, there is a normal force, there is a frictional force. The friction must always be parallel to the surface of the slope. Hello, thank you. Then from there, they said use energy principles to calculate the vertical height from point D to the ground. From point D to the ground, we need Mr. H. How are you going to get that Mr. H there? From C to D, arne the displacement. Can you see that? From C to D, you don't have the displacement sharp. The height. Which formula are we going to use because there is a non-conservative force? Sure. Work done by the non-conservative force equals the change in EP plus the change in EK. Okay. EP we know that is given as mg H final minus mg H final, oh no, my bad, initial plus mg, half mv f squared, initial, oh no, final minus the half mv initial squared. So this is the change in EK, change in AP, and then I can start to substitute. But before that, I need to resolve Mr. Work done by the non-conservative force, alright? So the work done by the non-conservative force here is that it is done by someone. Here is the person who? Frictional force. So we're going to have work done by the frictional force in this case. Let's kakamola it. Ne? If you want to kakamola it nicely, you will say frictional force, change in displacement, cos of theta. I hope it makes sense because we know that work done equals to force, change in x, cos of theta. This is the formula of the work done on an object by any force, right? So since we know that the force that is present is basically the frictional force, we gotta apply that guy there. Alright, awesome. Now I'm gonna put my mass, which is 80 kg. I have my height, the final one. This is the guy that I'm basically looking for, right? 9.8 is constant. I'm having the h, and then minus the mass. Okay, it's important. It's just gonna be that 80, and then I'm having the 9.8, 0. Okay, the reason why it's 0 initially, when he was here, there was no any height. I think it should make sense to you. Like, I'm still at the ground, my people. You get? So you can't be telling me there is a height there. There's no height. That's why you gotta put 0. Making sense? Thank you. Then from there, I'm gonna say plus. Plus who now? Half, the mass 80, the speed, which is finally 0 meters per second squared, all squared. Remember they said when he got to the point D, he was at rest. Sure. Minus the half, the mass 80, into, who is that guy? When he was at the point C, from that point A, he was speeding up with the speed of 31.3 meters per second until he reached point D to be at rest. So I'm going to put that 31.3 meters per second. I don't have to put it, it's fine, all squared. Sharp, my people. My people, substitute. Where you see this guy, put 160, changing displacement. I don't have you, I know. Okay, cos theta, cos of, the question is here, my people. Which angle are we supposed to use? Whenever there is a force applied, if this is an object, right? If this is an object, you can see, and I'm applying a force, my force is parallel to the direction of the displacement of an object, the angle becomes 0 degrees. Whenever a force acts parallel to the direction of the change in the displacement of an object, you must know that the angle is 0. Sharp. If ever the force acts in the opposite direction, and we know the only person who can act in the opposite direction of an object, it is basically a frictional force. The angle is 180 degrees. It's always like that, doesn't change. Okay, And you know, cos of 180 is basically negative 1. That's why we end up having a negative work done. A positive work done is done by the force that is acting parallel, okay, which is 0. So I'm going to end up having, come on James, you got this. I'm going to end up having the answer as negative 160 change in x. That's what I'm having. And then this guy, I can try to tatamula him fast. Okay. That one is 0. We sorted today. 80 times 9.8. We have 784. So I'm just going to write, let me write it nicely. Okay, we have the 784 minus the 0. 0 is gone. I'm not going to add it. Plus who? This guy is also 0. I'm not going to add him. Minus. Oh no, I'm supposed to put h here. Okay, I'm supposed to put the h minus the he can go. I don't want him. This guy, he can also disappear. Is 0. So I'm just going to put minus what? That guy there. It's half into 80, 31,3 all squared. Then I have minus 39187,6. That's basically what I'm having, joules. Okay, so I'm having a big problem because my examiner asked me to determine the age, and I don't have the displacement as well. So it's a very big problem. But don't worry guys, I got you. This is why you have Mr. James, the decomposer and the synthesizer of math and science tutor, because I'm about to decompose something for you and synthesize that guy for you. Now let's break it down. Let's decompose this guy. So we are asked to find what? The age. And the examiner, he was too smart to give you the what? The angle, which is 30 degrees. What do you think you're gonna do with this angle? This thing is a piece. So link to it. Alright. Yeah. So now, check it out. What's happening here is that you are basically having a right angle triangle. This is your H, this is 30 degrees, this is Mr. CD. Okay? Now, we know that this CD is the same as the displacement, isn't it? Because that's where the object is supposed to be. Making sense. Someone got it there. Thank you so much. Now check it out. I need to find the CD in terms of H. I'm gonna say using the trig ratio that could have H. Let's think of tan. Tan is basically opposite adjacent. I don't need the tan. Cos is adjacent hypotenuse. Who? Sine. Opposite then I can use opposite and hypotenuse there. So I'm going to have sine of 30 degrees equals to the opposite side is the H, the hypotenuse is my CD. Let's make CD to be the subject of the formula. Right, so I'm going to be having CD equal to H over sine 30 degrees. Okay, believe me guys, CD, if you simplify Mr. Sine theta further, you know this guy's a special angle is going to give you half. I'm going to end up having H over half. And guys, if you're remembering, basically the CD is going to be equal to your 2H. Now, let me just put it in this way again. If you remember your fractions very well, you have H divided by half. This is the same as H times 2 over 1. Over 1. H times 2, 2H. 1 times 1 over 1. Anything divided by 2H. That's why we have CD as 2H there. Then from there, I'm have wherever I see CD, which is my change in displacement, I'm going to put in there. Check. Minus 160 into 2H equals to, I need to rewrite this thing nicely. Let's write it here. Minus 160H. No, sorry. Let me just multiply that guy. So we'll have minus negative 160 times the 2. I have minus what? 320. H equaling to, we take this guy to the other side. Right? I guess this guy was equaling to everyone there. I just have to simplify it is here. So this guy when it comes is going to become negative 784H, right? Equaling to this one is supposed to be negative because it's minus here. So it's negative 39187,6 joules. That is our energy. Okay, just be with me, my people. Okay, and then from there we are going to say that guy minus 784, and then I get minus 1104H equal to 3 negative 39187,6 joules. Let's divide both sides by this guy because we're looking for the H. Then I'm going to divide H at the end of the day equals 2. So minus 39187 divide 6 divide by the answer we got, and then my height was 35,496 going there. So H is approximately what? If ever they said we are rounding it off, we can just say it's 36 meters basically. But in 2 decimal places, you can just leave it's gonna be 35,50, like 35,50 meters. So these are basically your answers. In 2 decimal places is this guy. Yeah, if you are just rounding off in G, sure. So this is basically how you must determine the age given to you. Excuse me, because people are gonna be struggling with how to find age. A lot of people are gonna get stuck. They'll be like, there's an error. There's no error, Bafetu. There's no error. Please, from today you must know. This is how we break it down. You see how I had to break it down. Then I had to synthesize it, and then now you saw how we had to use the trig ratios. Guys, this physics, you must apply the mathematics, okay? And that's trig, right? I'm saying that is trig, basically right there. So I told them, stay blessed, stay tuned. More is still coming for you. Love you.